Hi, welcome to Introduction to Codespaces. Here, we are going to learn to code anywhere without any local setup. I'm Dina Smiley. I'm a senior software engineer at RangeMe, and this course is a summary of things I've learned from some courses and also from my very talented colleagues. Let's see what is our journey here. First, we are going to have a quick demo of what we get. Then, we are going to learn what is a virtual machine, what is a container, and then we will learn some basic information of Docker and what is a dev container. Then we are ready to know what is Codespaces, and we are going to have some practices around it, including creating a Rails and Mariadb application on Codespaces. First things first, let's have a quick demo of what we get from Codespaces. I'm now on my GitHub account and this is a private repository I have. It's a pet project and it is written in Laravel, PHP, and MariaDB. I don't have PHP or MariaDB installed on my local computer, but it's not a problem. If I want to work on it, I can just come here to the code tab and then change the tab to Codespaces. I already have one Codespace on the main branch of my project. I can click on it and open it. And here we go. My code is here and I can start working on it. Let me show it to you. You can see that I'm recording this video on a MacBook. This Apple icon shows that. But let's check which operating system this Visual Studio Code is connected to. This Visual Studio Code inside the browser. So inside the terminal, I'm typing uname -a and wow, I'm connected to an Ubuntu server. It's not my local environment. So to run my project, first let me clear my screen by pressing Ctrl L. And then because it's a Laravel application, I can type PHP artisan serve. And the application is started on this port. It shows me this pop-up to open it in the browser. If by coincidence I close it, I still can come here to the ports. I have it here too. I can click on open in browser. And here we go. This is my application. And this information are coming from database. If I click on it, you can see that this information are fetched successfully from database. It's pretty cool, hey? But it's even better than this. Let me close this window and then I'm going to stop this instance of Codespace. So I click down here on Codespaces and I'm stopping it from here. Now I'm going back to my project. Imagine that I want to work on another branch to add a new feature. I can come here to branch and create a new branch. Let's call it add nodes, which is from the main branch. Then I can create it. If I want to work on this branch, I can just go there. From the code, I can create another instance of Codespaces. Very easy. I can come here, new with options. Then I can select 2 cores, 4 core, or if you need more, you can ask GitHub to give you more. And then I create it. It's going to be almost the same thing, but from the new branch. When I'm done with that, I can just commit it, push it to the server, and then merge it to my main branch. And then I'm ready to deploy my main branch to my server. Easy peasy. Did you like the demo? I hope so. If you want to work with Codespaces before everything, we need to understand some theory. So let's start by this. What is a virtual machine and what is a container and what's the difference between them? Let's start by virtual machine. What is a virtual machine? It's an emulation of a computer system that runs on another computer or host system. But what does that mean? Look at this diagram from bottom to top. At the end, it's our first layer, a hardware layer. It has a CPU, RAM, network adapter, and other things that a computer has. Then we have another layer, the operating system layer, which it can be a regular operating system like Linux, Windows, or Mac OS, or it can be a lightweight operating system which is designed for managing virtual machine. They are called hypervisor. And then on top of this host operating system, on top of layer 2, we can have virtual machine which they are behaving like a separated, isolated computer. One of them can be Windows, the other can be Ubuntu, and the other can be FreeBSD. They are all like a computer, but in fact, they are sharing the hardware through the host operating system. And they are totally isolated. They are even isolated from the layer 2, the host operating system. Now we know what is a virtual machine. Now let's see what is a container. A container is a standard unit of software that packages up code and all its dependencies. But again, what does that mean? Look at this diagram from bottom to the top. First layer, we have a computer, CPU, RAM, network adapter. It can be a virtual computer too, a virtual machine. On top of this layer, we have this whole blue box. It's a Debian operating system. It's a Linux operating system. This Debian operating system, inside it has its own OS kernel, the Linux kernel, which is shared between all Linux distribution, and the Debian operating system has its own application layer, Debian application layer, and we can install Node 13 on this application layer. Now, what is a container? A container is an isolated application layer which share the OS kernel with the host operating system. So we can have the container 1, which is an Ubuntu container sharing the same OS kernel, and we can install Node 14 on it. It's going to be isolated from the host operating system. So this Node 14 is not going to interfere with this Node 13. We can have another container to there, an Alpine Linux, which is another distribution, which has Node 19, and they are not going to interfere with each other at all. So the difference between a virtual machine and container is that a virtual machine is to share hardware. Container is there to share OS kernel. And container is much lighter than virtual machine. Being lightweight is also come with a restriction. What's the restriction? This container can be only hosted on a host with the same OS kernel. It means that I have an Ubuntu container, I can host it on a Linux operating system. But There is a good news. Windows 10 and above is shipped with a customized version of Linux kernel that you can install on your Windows machine. About macOS, it's a bit different. If you want to host a Linux container on your macOS, it actually needs a very lightweight virtual machine which has Linux OS kernel, and then you can host your containers on top of that lightweight virtual machine. Now that we know what is a container, we also need to understand what is a container image and what is a container itself. A container image is actually just a blueprint, nothing executable. So for example, we can have an image of Ubuntu 20, Alpine 3, or Ruby 3, which is installed on Debian Bullseye. They are not executable, but to create a container, we first need to fetch them from a hub and put it on our computer. And when we have the image, we can now run one or multiple containers from that image. For example, we can get an image of an Ubuntu 20, and then from that image, we can have one or multiple Ubuntu containers running on our computer. Now that we know what is a container and a container image, how to create them and how to manage them. To do that, we need a software installed on our machine. The most famous one is Docker that you can install it on your computer. There are other ones like Rocket, but Docker is more popular, and Codespaces use Docker too. It's why we are talking about Docker and containers. And how to find Docker images and run containers from them, we can go to this URL hub.docker.com, and there you can find thousands of container images. You just need to search it here at the top, and you don't even need to create a Docker account for that. Now it's time to learn some Docker commands. After installing Docker on your computer, these are the most commands that you are going to use. First, Docker pull. It is used to get an image from Docker Hub and put it on your computer. So here, when we type Docker pull Mariadb, the Mariadb Docker image will be placed on your computer. Now that we have the image, if we want to create a container from that image, we can use this command. Docker run dash dash name. The name of the container is different from the name of the image, is an actual executable container. Dash e followed by some environment variables. Here we are setting the root password of that MariaDB instance. Dash V to set some volumes. In this way, you can map some local directory on the host to directories on the container. In this way, when you shut down the container or replace it with another container, you are going to have your data saved on the host. Dash P to define some ports. Always the host is on the left side, the container is on the right side. We are mapping a port 3306 of the container to the same port number on the host. Dash D to be detached so we can type the rest of the things on the bash, and the name of the image, MariaDB. Now we have the container running. How to connect to the bash commands of the container? We can use docker execute dash interactive it container name, here my MariaDB bash. If the container has bash installed on it, Ubuntu, Debian, they have it. But if you are using Alpine to use a lightweight container, then Alpine doesn't has bash, so you need to put it sh for shell only. If you want to see the images on your computer, you can say Docker images or Docker image list. And if you want to see the containers, all the containers, you can see Docker ps-a. If you don't use dash a, it's just going to show you the running containers. If you look at this command, we are using an already existing Docker image. But you can create your own images too. Here, I asked ChatGPT to create a Docker image for me to run a Node.js application. I asked ChatGPT to define the Node.js version and a MongoDB for it too. And it did a good job. Here, we are using a base Ubuntu image. It's going to create an app directory inside the container and switching to that, then updating the list of packages in Ubuntu, and then going to install Node 19 and then MongoDB, and then it's copying the current directory to the app directory of the container, and then we're ready to go and start our Node.js application inside a container. We need to understand the basic of it to work with code spaces, but copying the files inside the application is something that we don't need when we are dealing with code spaces because it's happening automatically with code spaces for us. To work with code spaces, we don't need to have in-depth knowledge of Docker. Basic knowledge is enough. The things that I showed you is most of the things that you need to work with code spaces. At the end of these slides, I'm going to show you some courses that you can go and watch it on YouTube. One of them is about Docker. But meanwhile, if you have any question about Docker, ChatGPT is a good resource. It's a part of my conversation with ChatGPT, and I can tell you ChatGPT is very helpful when you need to work with Docker. Okay, I know that you like to jump to the practice part, but you still need to learn some more theory, but it's going to get finished soon. Docker Compose is another thing that we need to know it. What is Docker Compose? It is actually a YAML file, very readable, called docker-compose.yaml. It has this format, started with version, which should be an string, although it is a number, followed by services, and each service, in fact, is a container that we would like to run. Here we have only one of them called DB, and the image of it is Mariadb, the latest version, with this environment variable, and then this volume 2, not losing the data generated by actually the Mariadb container. Here, this YAML is generated by ChatGPT and the secret is used here, but we have to change it if we want to actually use it because secret I think is blacklisted and we cannot really log in with root and secret to MariaDB. When we have this docker compose.yaml, then we can use this command docker-compose, which is a part of Docker CLI. It is installed by Docker when you install it on your machine. So docker-compose off and then -d to be detached. So it will create the process and then it release it. So release the bash so we can start writing other bash commands that you have. Here is another sample of Docker Compose. We are going to practice this one on Codespaces. And in this one, we have multiple containers. We have, in fact, two containers. One of them is DB, which is MariaDB 10 with these options. One of them is to restart it unless it is already started, port mapping, a volume, and this environment variable. So we are defining what is the root password and creating one database with a actually username and password. And here we also create one phpMyAdmin container to manage this one with these options that it always restarted and it does a port mapping, so we can actually access the port 80 of this container through the port 3030 of the host. And by this environment variable, we ask it to let us always log in with defining which database server. There is something good about Docker Compose. It has some sort of DNS inside it. So then inside this PHP my admin, it's a totally isolated container from DB. If we want to connect to this one to other service, we can just use the name of the other service, DB. We are going to see it later. In Docker Compose, we also need at the end to define the volumes that we have used. It is something that exists in Docker Compose. Time to learn the last piece of this puzzle, dev container. It's also called remote container. What's that? It is something like this. Consider that we have this container one. We have Ubuntu, Ruby, and Node installed on it. This container is actually connected to more containers, perhaps through a Docker Compose. One of them can be MySQL, the other one can be Redis, and you name it. Then imagine that we can connect our Visual Studio code remotely to this container and write the code there on the container. It is called dev container or remote container. Before recording this video, I shared my slide with my colleague and he told me that this image is very descriptive about dev containers, and he's right. This image is from Visual Studio Code website, and here we can see that we have a container. It has its own file system and the requirements are installed on the container, Ruby, PHP, .NET, you name it. And then in this container, we also have another software, VS Code Server. Now that we have this container running, we can connect our Visual Studio on our local system to this container through the VS Code server. We can also share the source code through the volume mounting to the container, and then we are good to go. Our requirements are installed through the container, and we don't need to install a single thing except Visual Studio Code on our local. Dada, it's the golden moment because we can say what is a code space now. A code space, in fact, is a remote virtual machine out there on GitHub. I can say perhaps on Azure environment. And then on this virtual machine, we have a dev container, which the things that we need to be installed there, maybe Ubuntu, Ruby, Node, and other things. And then this container can also be connected to another container, maybe your database or Redis and other things that you need. And then we can have a Visual Studio Code through the browser or even from your local system connected remotely to this dev container on that remote virtual machine. It's the way that we can develop any web application out there right on the GitHub. It's time to make our hand dirty. Let's explore the Codespaces default dev container. It's what we get from Codespaces with no settings. To explore the default dev container of Codespaces, I have one empty repository here. If you already have a repository with code inside it, it's going to behave the same if you don't have a dev container configuration. Now I'm going to code spaces. I can use this to create a default code space environment for this, or I can come here from these three dots and go and choose new with options. Here I want to work on main branch. I'm in Australia, so here the region is good for me. And I'm going to choose 4 core to be faster. It's going to create a container on a virtual machine out there on Azure environment. It may take few minutes. It's pretty fast for the default web container. And here we go. We are there. It's the README file, so it is the only file I have in my repository. And here is the terminal. Let me make it bigger and zoom. Now I'm going to clean the terminal with Control L. If I type uname dash A, we are on Ubuntu server. Now if I type, for example, ruby-v, you can see on default we have Ruby 3 on it, php-v, we have PHP 8 on it. Let's say Python dash version. I guess it is dash dash version in Python. Yes, we have Python 3 on it. Even we have .NET on it. Here we go, .NET 7 installed on it. Node, and you name it. Most of the up-to-date programming languages are already installed on it. So to do some practice, I'm just coming here, creating a new file. Let's say test.rb, a new Ruby file. I need to turn off my Grammarly all the time when I'm using Codespaces. Here I can say put S and then hi and save it. Then back to my terminal. Here I can type ruby test.rb and it put the hi for me there. And even if I type docker -v, you can see that Docker is even installed on this dev container. But there is a point about it. I'm going to talk about Docker in Docker very soon, so we can use Docker on the dev container to practice Docker. You notice that Docker is installed by default on the default dev container on Codespaces. But I have to tell you about this topic, otherwise you may get crazy there. The topic is Docker in Docker or DND. What is Docker in Docker? Let's look at this diagram. We have a host here, and here on this host we have installed Docker. We have a Docker daemon there, and we have the Docker CLI there. The Docker CLI is the tools we use to run Docker commands or Docker compose. Something like Docker pull, Docker run, Docker images. And then what does the actual job is Docker daemon. Now imagine that on this host we are running this container. Inside this container, we can also install a Docker CLI, a Docker inside the Docker container, DND, which is connected to the Docker daemon of the host. So what does that mean then? It means that if you use this Docker CLI to execute any command, it's going to be executed on the host but displayed to you on the container. And this is what we have on dev container on the Codespaces. So if you run a Docker container there, the container is going to be executed on the host. It's going to be a sibling of this container, something on the side of this container. And if you forward ports, the forwarded ports are going to be on the host, not the container. So you are not going to access through those forwarded code to the new container that you are going to run. Now that we know what is Docker in Docker, let's jump and practice some Docker commands inside Codespaces. All right, now it's time to practice Docker inside Codespaces. I have one public repository for that. It's a very simple repository. To access that, you can go to github.com slash the dash dina me slash docker dash demo. So here I'm going to go to code again, Codespaces. I'm going to create a new Codespace instance with 4 core to be faster. And we are going to land to the default dev container of the Codespaces. It's ready now. So here we can see that I have a README file here. And this, inside this folder, mariadb-php-myadmin, I have this docker compose.yaml. What we have inside it, let me first disable Grammarly here. Here we have defined the version of our Docker Compose. Then we have defined one container, which is a MariaDB container. And then we have a phpMyAdmin to explore this container. The MariaDB one is version 10 and it's forwarding the port 3306 of the container to the host, and this is the root password, MariaDB. Let me close this pop-up. So to work with it, I can just come here to my terminal. Let's zoom everything. And then here, let me clear by Control L. I'm going to MariaDB phpMyAdmin and directory. And here I can say docker compose of dash d. What did I miss here? Okay, a typo like always. And here we go. It's going to pull the images and then run the containers for us. Okay, they are ready now. You can see that a pop-up appeared and say that this port is now ready to be used. What is this port is coming from? It is the port of phpMyAdmin. You can see that I forwarded the port 80 of that one to port 3030, so we can access that from this port. If I go to ports, you can see I can go here and click on this. It will open the phpMyAdmin here, and you remember inside this container, if I want to get connected to MariaDB, I can use the name of it, db. So here I'm going to say the server is db, the username is root. If we go back to our Docker Compose, the password of root is MariaDB. Let me copy it, then login. Cool. We can see that we can access the MariaDB using phpMyAdmin here. Let me close this one. Now let's practice something else. Let me go back to my terminal and open it and clear it. So I want to get connected to MariaDB through the command. So first thing that I need to do is to actually install MySQL or MariaDB client. To do that, I can say sudo apt get update to first fetch the list of all packages on this Ubuntu. Package list is now updated. So what I can do is to say sudo apt get install mariadb dash client. So it is installing the MariaDB client. I'm pressing Y. If I wanted to install it without pressing Y, I could write -y. It is useful when you are using it inside a setup file, something like that. Now my MariaDB client is also ready. Let's do something. Now if I say MySQL dash host perhaps, which host? You may expect that it is DB from our Docker Compose, and then dash U root dash P. Here the password is MariaDB from Docker Compose. It says that it cannot find the host, which makes sense because this dev container is not part of the containers we configured inside the Docker Compose, so it doesn't know what is DB. How we can get connected to that MariaDB then? We actually needs to get connected to the host, and you see that the port is forwarded to host, so we can use the forwarded port from the host to get connected to MariaDB. Remember that we are now inside this container and port forwarding has been made through the host. So to get the IP address of the host, perhaps I can type IPADDR. Here we go. This is the IP address of the host. So now here, let me clear again. MySQL dash host. Let me allow it to paste it. The IP address of the host, then dash U root dash P. Okay, something went wrong. Let me see what is that. Dash U, asking for password, MariaDB. Here we go. Now I'm connected to the MariaDB container, so I can execute queries there. Let me clear it. I can say show databases, semicolon, and it's the list of databases we have inside the running container. It's exciting, isn't it? But actually, you don't need to go and run the Docker Compose inside the default container. There is a better way to do that. And in next practice, we are going to set up everything you need to actually run your application through Codespaces. And I'm sure that you are going to enjoy it. Let's have another practice to learn more about Codespaces. In this practice, we are going to create a Rails and MariaDB application from scratch. If you are not a Rails developer, you are still going to get benefits of watching this part because creating other kind of applications more and less is almost the same. I already have created one public repository. The address is github.com/the-dina slash rails.mysql slash codespaces. And as we know, MySQL and MariaDB are compatible, just MariaDB has better license. In this repository, if you go to commits, you can follow me step by step to create a Rails application and a MariaDB application from scratch. But to learn more, we are going to use an empty repository, although I'm going to use this repository as a cheat sheet. All right, in my empty repository, I can again come here to Codespaces, and you can see I already have one active running instance of Codespace. I did it to save some time. Here we go, it's that, and it's running the default dev environment. So here, let's tailor it for our Rails application. To do that, I'm pressing Command Shift P, and then we can type dev container and select this one, configure dev container. We can select from scratch, and then we should click on show all definitions. Now I can search Rails. I have two options here, Rails without database or Rails with Postgres. It is closer to what I need. I just need then to change the Postgres to Mariadb. So let's click on it. Which version? I'm going to choose 3 on Debian Bullseye. I think it's more stable. And then here I can search for Node.js as a feature that I'm going to add. Here we go. I selected that. We can select other things, something like Docker in Docker or dev container command line or any other things that you wish. I'm clicking on OK, and it's going to create some files for us. You can see I'm already on the Explorer, and it created this directory for us, dev container. Whenever we start a code space, Codespaces is going to look at this folder and execute this JSON and whatever is directed by that. So we have 3 important files here. This one is not required, so I'm going to delete it. The files that we have here, one of them is this Docker file, which is in fact the dev container that you are going to use to develop your Rails application. We can see that the base image is Bullseye. Let me turn off my Grammarly. And then it's going to run this command to install Rails on it and set these environment variables to, in fact, whitelist some uh, these domains to be accessible later in our Rails app. Then it commented few things for us that we can uncomment and use it. For example, this one to install uh, more packages on our Debian, or I'm going to uncomment this one, and then I'm going to add Bonder to it. So when we are installing Rails, we are also going to install this gem too. What I have inside this YAML file, actually it's a pretty easy one. It has one app which is directing to this one, the Docker file. The other things that we have here is the database, which is Postgres, and that's it. Here we can see that it has defined some actually um, volume for us too, which is actually a cache. It's not important, but thanks to it to configuring everything for us. And then we have this dev container.json that is going to say that which of these containers is the dev container. It is the app one and few configuration that we are going to tamper with it. First, let's change it to MariaDB. Then I'm going to do few more things. I already know that I need it to be the root user when I execute my dev container, or otherwise the some of the commands that I'm going to execute to install Rails, the Rails application is not going to work. So let me uncomment this one and put a comma here. So now I have a valid JSON. The things now I need to do is to change this DB from Postgres to MariaDB. I'm lazy, so let's see how I'm going to do that. I'm going to right click here and rename it to dev container copy. Now I'm going to do something else. I'm pressing Command Shift P and going to choose configure dev container again. Then from all definitions, I'm going to search for PHP because PHP developer usually use MySQL or MariaDB. So I can now select this one on any version, doesn't matter. We are going to delete it. No feature. And we are having these new files here. This one is actually configured for PHP MariaDB. What we are going to steal from this code is to come here and you can see how to create a MariaDB container, in fact. I guess this code is familiar to you. I already have used it in the previous practice to create a MariaDB inside my Docker Compose. So I'm copying this and then let me copy it. Then I'm coming to my Docker Compose. I'm selecting this database and here we go. One more thing, we can see that inside our Docker Compose, we need to define the volume. The volume that is defined here is different. So let me go there, select this one and change it here. We are almost good with our Docker Compose, but I still want to add one more thing to it. So first thing first, let me go and delete this dev container, which is the PHP one. Permanently delete it. Rename this one back to dev container. And from the previous practice, I'm going here on tab and I'm pasting this phpMyAdmin container so I can easily manage my database when I'm going to use this dev container. Let's stop to this point and build our dev container to get sure that everything is working. To do that, I can either come here, this button, and click on this and choose full rebuild or rebuild, or I can press Command Shift P and search for rebuild. Let me rebuild the dev container and see that if it's working. It's now rebuilding the dev container, image found, and it's going to take something like 2 to 3 minutes, depends to the power of the virtual machine. I asked them to give me more than 4 cores, so I'm waiting for GitHub response, but I'm going to pause it for now and come back when the build is ready. It took around 2 minutes and now our raised dev container is ready. So let me close this and actually clear my terminal. I'm going to zoom so you can see it better. Here, if I type ruby-v, it is 3. And if I now type, for example, Python dash dash version, you can see there is no Python there. It is because now we are using a customized version of dev container and it only have Ruby and Node installed on it. Okay, I'm going to tamper the dev container too. I already have the code I need inside the memory, so I'm just going to paste it here and explain what's going on here. first I change the name, then we have some customization which contains adding extension to VS Code. This is the VS Code that is running here. We can customize that whenever we run this dev container, we want these actually extensions or plugins to be there. How we can find these IDs to add it? We can just go simply here inside extensions, and then it's going to show us the list of extensions. For example, it's recommend us to have this Docker one. If I want to add it, I can from the right side scroll down and copy this one. Then I can come here and put a comma and add it here. I'm not going to do it now. The next thing is that this feature was from the previous code, so I didn't change it. The next thing is that I have defined which ports are going to be forwarded. These are the ports. This one is for the Rails application. This one is the PHP and this one is the actually the MariaDB. We don't need to always do that. When a port is activated, Codespaces will find it out automatically, but it's a good practice to do that. Then as another good practice, for each of these ports, I have defined what they are doing. And then we have this line, which was previously commented. What it does is that actually it's going to run this file whenever the code space is ready. I just need to change something, because if I go to my command, you can see it's a different repository. So the path is workspaces slash empty. So let me change it to this, and I need to create this file too. So whenever the code space is ready, after building the containers, it's going to execute this file. It's a good point to install more requirements. To do that, I'm coming here. I'm creating a new file, dev.setup.sh. It is created. Here, I'm going to clear my terminal. And because I need to execute it, I need to change the permissions. How we can do that? Using chmod, modify the permissions. And I'm going to give all permissions 777 to what? Dev setup.sh. Then I'm going to paste some codes inside that file. I need to allow pasting here. Oops, I didn't want it in my terminal. So what can I do here? I can just press Control C to not do anything. Then cleaning this. I needed to paste it here. So here what we are doing is to get the list of packages and update the list of packages in our server, in fact our container, and then we are installing MariaDB client, and this package which is required to get connected to MySQL from Rails application, it's inside the document. I actually took it from, I guess, this container file. You can see at the end it was from another container file. You can see what it does, it just clean up things. Then it means that our code space is going to get less in fact space, and when it is inactive it's going to cost us less if we pass the free tier. We fortunately as a developer we have a big free tier, something like 60 hours per month if we just use 2 core virtual machines. Then I have this commands to be executed when my Rails application is ready. It's not ready yet, so I can just comment it at this stage. And now what I have to do is to rebuild it again. How to do that? Command Shift P, and then I can choose rebuild container. And I'm going to cross my fingers. Rebuild, and let's go. Okay, the build was successful. It's going to run this one too. To get sure that it is executed, I can do something. I can come here because Mariadb client is installed. I can type mysql host. Now this time from the composer, I can just connect to, let me close this. I can just connect to the DB because I'm already in this container, the app container, and they are in the same network. So I can say mysql-h for the host, and then the host is DB, the user is root, and I need to enter password, which are all defined in this composer. You can see the password is MariaDB. Let's go there, MariaDB. And yay, we are there. So if I clean it, show databases, semicolon, we are ready. We have actually our Ruby, we have database. So let's create the Rails application. Before generating my Rails application, let me do something. I'm coming here to first stage everything and commit these. Let's say dev container. Done. I can even push it to the server. So I know I'm not going to mess with the things that I already have done. Then here I can type raise new in the same directory, and for the database MySQL. Yes, I'm going to overwrite the README file, and it's going to fetch all the gems. Now we are ready. Let me clear my screen. The next step, I can go to actually my database configuration. Let me close this one. The host is DB because it's the name of the container. The password is MariaDB. We know it from the Docker Compose. And this one is correct. The username is root. Now I have this. Let me bring up the terminal again. So now if I say raise db create, it should create the database for me. It is created. To get sure even, we can see from the message, but we can even go here using our phpMyAdmin and explore the database there. Server is db, username root, password MariaDB. And we can see that these are the development and the test database there. Let me close this one. So we are now ready to actually run the Rails server. Let me clean it again. So Rails S to run the server. The server is now running on port 3000. I can open it here. And here we go, the default good old Rails application. Now that I have the working Rails application, let me go back here, and here I can come and commit everything I have, Rails base app, and commit it, commit everything. Let's put it on the server too. And then I can come here and I can create a model, Rails generate model book. So things now is created. I need to go to the migration. So create book. Here I can say that I have one string here, which is author. Then I can save it back to my terminal. Now I can say raise db migrate. Let's do that. And it is now created, I guess, or something went wrong. So it says that I don't know the local variable author. What's wrong with this one? Hmm, yeah, I have to use symbols here. So let me save it again and try to run the migration again. And now it is created. So let me commit this one to book model. There is only one more thing I need to do for this Rails application. And this is that here in my dev setup, now I have to come and uncomment this, because whenever the dev container is now built, I would like to create a database and do the migration. We can also define our seed file to seed the database. I'm going to show it in the other repository that I have, because to save some time, I already have created controller and everything there. So I change this one and I'm going to uh, commit this one to dev setup. And I will come back with the repository we already have. So you remember that I have created this public repository, which was the full example of the Rails MySQL on Codespaces. In this repository, if I go to Codespaces, you can see I have one active one, which is this one. Comparing to what we created together, this one, I also have created one controller on it, which send all the books to the view. And this view is going to create a table for it. I also, inside the layout, I added this style sheet, which is a common style sheet to make it more beautiful. And inside the rules, I added that books controller is the home page. And I also had done one more thing, and I have defined the seeds. So whenever we create the container in setup file, so which was that dev setup, after migrating, we are doing this seed. So whenever we create the container, these books are there. If in this repository I run the server, it's going to show me this notification. We can see that all those books now inside the database, and it's showing us through the controller. All right, I hope that you enjoyed this course and you found Codespaces is something useful for you. Personally, I really like Codespaces. Before finishing, I need to thank few people. Actually, the first person that I want to thank is Oli, my colleague at RangeMe. He's the head of infrastructure, very knowledgeable person that I learned a lot about Codespaces from him and reading through his pull request. The other one is this gentleman that I don't know him in person at all, but I watched this YouTube video which was something that he presented in a .NET conference in Melbourne 2 years ago, and I got very encouraged to know more about containers. And the last person, not a person, the last thing here that I want to thank is ChatGPT. I know that maybe eventually the AI is going to make me unemployed, but that's okay. ChatGPT helped me to learn a lot about containers and also dev containers. If you would like, you can start your conversation with ChatGPT too. So if you need some more resources, I have listed these playlists, and you can go and learn more about code spaces, dev containers, or Docker. Wherever I host this video, I'm going to put this slide so you can use it. And then now it's time to say goodbye. So it was nice to meet you, and take care of yourself and people around you.